In this video, we're going to be learning about the surface area of pyramids, cones, and spheres. So first, what's a pyramid? It's a 3D figure with a regular polygon as its base. So that's talking about your squares, your hexagons, pentagons, those kinds of things where they're all regular. And the lateral faces are identical isosceles triangles meeting at a point. So here are your formulas. Your lateral area is your perimeter times your L, which stands for slant height. That's the height along one of those isosceles triangles, divided by 2, or 1/2 PL is another way you could see it. And then your surface area is your lateral plus the area of one base, because there's only one base on pyramids. So here's our first example. Let's try it out. So my lateral area is 1/2 PL. Perimeter of my base, these are all 5. So that's going to be 20. My slant height is 8. Notice that it's this part that's along the edge. That's my slant height. So 1/2 times 20 times 8, and that gives me 80. So now the surface area is my lateral plus the area of the base. The area of the base is 5 times 5, which is 25. So it's 80 plus 25, which is 105. So here's our next one. This time we have a pentagonal pyramid. So the height is 8. The apothem is 4, and our side length is 6. So we need to calculate the slant height. If you notice there, that's a right triangle. So we're actually going to use Pythagorean theorem to do that. So my height and apothem are my A and my B. And then my slant height is my C. So then the square root of 80 is 8.9. So now we can calculate everything. Lateral area. My perimeter is 6 times 5. And my slant height is 8.9. So that gives me 133.5. And now the surface area, lateral plus the area at the base. My base is a polygon, so that's 1/2 times my apothem times the perimeter, which was 30. So that's 193.5. Here's our next one. Again, this time we have a hexagonal pyramid because we have 6 sides. So the only thing we're missing is our apothem. So we're going to use, I'm going to use special right triangles for this because I know that a hexagon creates special right triangles. So I know it creates a 30, 60, 90 triangle, so that's going to be 5, and this is 5 square roots of 3. So my apothem is 5 square roots of 3. So I'm going to go ahead and find all my pieces. Perimeter of the base is 60, the area of my base will be 1/2 5 square roots of 3 times 60. So that is 259.8. And now I can go ahead and find my lateral and slant height, or my lateral and surface area. Parameter is 60. Slant height is 22. That gives me 660. Now my surface area. And 919.8. So now we're going to talk about finding the surface area of cones. It's just like the pyramids, only now we have a circle for our base. So your lateral area is pi RL, where again L is your slant height, and the total surface area is the same thing. It's your lateral plus the area of your base. This time our base is a circle, so it'd be pi r squared. So here's our first example. Lateral area, pi RL, pi times my radius times my slant height. So this is 3 pi. I'm just going to go ahead and leave it in terms of pi. And then surface area, lateral plus pi r squared. So my surface area is 4 pi. So here's our next one. We know the radius is 3 and our height is 4. So this one, again, we have to use Pythagorean theorem to find our slant height. Once you do it, or if you recognize it, this is a Pythagorean triple. That means our slant height is going to be 5. So lateral area, pi RL. So my slant height is 15 pi. And my surface area is 24 pi. And our last shape is going to be a sphere. So a sphere is just a ball. It's all of the points that are the same distance from a given point in 3D. And one special thing about a sphere, it has this thing called the great circle. So this is just the biggest circle you can create around a sphere. So to find your surface area of a sphere, the formula is 4 pi r squared. And notice there is no lateral because remember, in order to have lateral, it's everything but bases. And bases can only be faces, which have to be flat, and spheres don't have any flat surfaces. So there is no lateral area for a sphere, it's just surface area. So my surface area is 36 pi. Okay, here's our next one. Find the surface area of a sphere with a great circle that has an area of 49 pi miles squared. So area of a circle is pi r squared. Well, the surface area is 4 pi r squared. So we just need to take this area and multiply by 4. Take this area right here and multiply by 4. And so that's going to give me 196 pi. If you weren't able to recognize that, what you can do is say, oh, well, my area, 49 pi, is pi r squared. And then I'd solve for my radius. So these pi's cancel each other out. So 49 is my radius squared, so my radius has to be 7. And then I take it and I just plug it into my surface area formula, and I'd get 196 pi. Last one. This time we have a hemisphere. So it's only half of a circle. And you're going to be tempted to say, well, since it's a hemisphere, it's only half, that means my formula must be 2 pi r squared, right? Because that's half of 4. You're really close. The only thing is about a hemisphere is now I have created an extra circle right here. So I have to remember to add that back in. So 2 pi r squared would get me all of the curved surface right here. But then I have to add that last surface, that last circle that I just cut. So the surface area is actually going to be 3 pi r squared for a solid hemisphere. And my radius is 6, so that gives me 3 times pi times 36, which is 108 pi. And that's the surface area of that hemisphere.